Graphing Absolute Value Equations Part 2. In this video, we're going to discover the effect of a constant inside the absolute value with x, and then we'll graph absolute value equations of the form y equals a times the absolute value of x minus c plus another constant b outside. We'll be using the constants to shift and expand or contract the basic graph. In the last video, we looked at what happens to the absolute value equation with a multiplier and or a constant added outside the absolute value. So if the multiplier is greater than 0, we have a v facing up. And if multiplier is less than 0, we have a v facing down. The arms of the v have slope minus a and positive a, respectively, and the vertex is at the point 0b. Now we'd like to explore what happens when we have an equation where the absolute value includes a constant inside. So something like the absolute value of x plus 2 all inside the absolute value markers. To figure out how the absolute value graph is changed by adding 2 to x inside the absolute value, I'm going to start by making a table. When x is negative 1, I have the absolute value of negative 1 plus 2. And that gives me 1 inside the absolute value, so I have the point negative 1, 1. When x is 0, 0 plus 2 inside the absolute value gives me 2. And when x is 1, I have 1 plus 2 inside the absolute value, and that gives me 3. So I'm going to plot those points. Negative 1, 1 is right here, 0, 2 right here, and 1, 3 right here. To see the graph clearly, we're going to need a few more points. Let's make another table. How about when x is negative 2? Well, the absolute value of negative 2 plus 2 is 0. So I have the point negative 2, 0. How about negative 3? Well, negative 3 plus 2 is negative 1. The absolute value is 1. Negative 4. Negative 4 plus 2 is negative 2. The absolute value is 2. I can plot those points, negative 2, 0, negative 3, positive 1, and negative 4, positive 2, and now I'm seeing a V shape. It looks like the vertex is at negative 2, 0, and the V goes up, so it looks like my positive 2 has shifted the vertex of the graph to negative 2. That's interesting. Let's try another example. Let's figure out what happens when y equals x minus 3 inside the absolute value. Since y equals x plus 2 shifted the graph over to have its vertex at negative 2, I'm going to try positive 3 for x. Then y is the absolute value of 3 minus 3, or 0. And so I have the point 3, 0. Is that the vertex? So when I get to 4, I have the point 4, 1. What about 2? 2 minus 3 is negative 1, but the absolute value of negative 1 is positive 1. So I have the point 2, 1. And that makes a V here. I have my V shape just like before, only shifted to the right 3 units. There's two ways to write this conclusion about shifting. If y is equal to x plus a constant inside the absolute value, then the vertex of the graph is shifted to the point minus c, 0. Now that's often written this way: if y equals the absolute value of x minus a constant, then the vertex is at the point C, 0. These say the exact same thing, it's just a matter of where we put the negative. Most books have it written this way. The effects of the two different constants combine nicely. The plus 3 outside moves the vertex up to 3, and the minus 2 inside shifts the vertex right to 2. So the vertex of this graph is at the point 2, 3. There's no multiplier, so the slope is 1 on the right and negative 1 on the left. And we're able to graph this quite complicated equation just by looking at the constants and understanding how they work. Let's try putting all the effects together. I have a 1 inside. It's a positive 1, so it shifts in the opposite direction, and the vertex should be at x equals negative 1. The minus 3 outside will give the y-coordinate of the vertex. It's going to be at negative 3. So my vertex for this graph is at the point negative 1, negative 3. That's using the constants that are added and subtracted. Now what about this negative 2 multiplier? A negative multiplier turns the v upside down, so I'm going to have a v that's pointing down, and negative 2 makes the slope negative 2 on the right and positive 2 on the left. So I have a narrow v facing down with vertex at negative 1, negative 3. So in general, if I have an equation, a times the absolute value of x minus c, and then b added, I'm going to have a facing down v if a is less than 0, a facing up v if a is greater than 0, and it has slope a on the right-hand branch and slope negative a on the left-hand branch. The vertex of the graph is going to be at the point where x equals c, because c minus c gives me 0 inside, and y equals b. And that's true in both cases. The vertex is at cb. So knowing what the constants do to an equation is so useful and makes graphing much, much easier and faster.